Welcome, everyone. We're going to go ahead and get started. I'm sure some people will join in during these opening slides. But my name is Abby. I'm a program manager here at Solar Oregon, and you're at one of our key educational webinars that we do regularly, our How to Go Solar and Storage presentation. Without further ado, we're going to jump right in. So on the agenda for today, we're going to be covering how solar works, some things to consider when you are trying to decide if your home is right for solar. Then we will dive into the exciting topic of home energy storage before talking about how you can pay for some of the things we're going to be talking about and the various incentives that are available before finally going through how you can get started. Really quickly, Solar Oregon is a nonprofit organization. We focus on education, outreach, community, and advocacy around solar power. We do a variety of different events, including our Hallmark How to Go Solar and Storage presentations that we've been doing for over 20 years. In addition, we do solar home tours and tours of interesting solar projects throughout the state of Oregon. We help out with Solarize campaigns, and we do a variety of different peer-to-peer education events. You can support our work by becoming a member today, and you can donate at the link here. And you can also follow us on social media and on Eventbrite at Solar Oregon in order to know what's going on and stay involved. We have some upcoming events. We have our solar wine tour happening in 2 days. The tickets are still on sale. There's still some available, but they're going fast. So if you enjoy the presentation today and you want to learn more about solar, I highly recommend checking that out. This presentation is made possible by the support of Energy Trust of Oregon. And before I talk about them, I'm going to actually launch a quick poll really quick. I'm going to launch 3 different polls before the presentation really gets going and one at the end. All of these are completely optional and all your information is private. It just is for our own data. So really quickly, here is the first poll. Energy Trust of Oregon is an independent nonprofit that is funded by the state legislature via the utility companies, and they provide access to affordable energy education and resources throughout Oregon. They serve 1.6 million customers of the Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista Utilities. Throughout the presentation, if you have any questions, you can use that Q&A button at the bottom of your screen in order to ask any questions. At the end, I'll be going through all the questions. There's no need to wait for the end of the presentation to put your questions in. You can put them in at any time, and I promise I will be going through them. I'm going to launch the next poll now. Okay, and one last poll. Awesome. Thank you so much for participating in those. One last thing is this presentation is being recorded. So if at the end of the presentation, you want to be able to go back and review some of the things that are talked about, that it will be posted on our YouTube channel in a few days. So now without further ado, let's go into how solar works. Here's a diagram of a basic solar system. You have the photovoltaic panel pictured on the top left here. This is your solar panel, also known as a PV panel, that when sunlight hits the panel, it generates a volt of electricity. However, that volt of electricity that is generated is DC or direct current electricity, which is different from the type of electricity, AC, that your home runs on. In order to convert that volt of electricity generated by your solar panel to usable electricity, you need to have another special device known as an inverter or microinverter. That converts the direct current DC electricity to usable AC electricity. From there, it flows into your home electrical panel, where it can be used by anything that runs on power within your home, be that a computer like I'm using right now, or your electric vehicle. If at any point in time you're generating more electricity than your home is using and you are a grid-tied solar system, the excess electricity you are generating will flow out to your neighbors, and you will gain through a new dual direction meter that is installed with your solar system. We'll be talking more about how you earn credits for that electricity you export through a process called net metering later in the presentation. But that's it. That's all the components of your solar system. All in all, it's very simple and it's highly modular, which is one of the reasons price can vary so much. We're now going to be diving deeper into some of the components involved. So first up, we have the inverter or microinverter. So pictured on the left is an inverter. This is a standard inverter, and if you have a solar array of 10 panels, you would have just one inverter. The inverter can take all the electricity from your solar panels at once and convert it all at once to be used by your home. Pictured on the right are microinverters. They're those little black boxes mounted up on the back side of the solar panel, like you can see here. Microinverters, as opposed to the string inverter on the left, take in the power from just 1 to 2 panels at a time. So if you have a 10-panel solar array, you could have up to 10 microinverters for your system. Both are really great options that are installed frequently throughout Oregon. It just really depends on the needs of your system and what your contractor and you decide is the best fit. Next up, we have mounting. So typically, what we see most commonly in residential solar are roof mounts, like pictured here on the left. This is when you put your solar on top of your roof. I know if you drive through Portland, you'll see plenty of roof-mounted solar systems taking advantage of some space that's already existed and doesn't take any extra space. However, if you do have that extra space to spare, ground-mounted solar systems, like pictured on the right, can be a really great option. They can be a little bit more expensive, as you do have to run conduit lines from your ground-mounted solar back to a utility meter and electric box and all that of your home. So it can bring in some extra costs, but they are also a great option if you have the space for it. Another option are solar roof tiles, which are pictured on the left. This is a solar product that is your roof. So rather than having your solar panels mounted on top of the roof, as in the last slide, your solar and roof are all in one. There are several different brands available. However, it can also be very expensive. Price declines have been predicted, but none have really come to fruition yet, and it's still a very expensive product, but can be a really great investment as it is both a solar product and your roof. Now I'm going to talk about net metering, which is that process I mentioned of how you can earn credit on your bill for any power that you're exporting to the grid. So I'm going to do that by first talking through 2 examples and then showing what your utility bill might look like. So first, we have a typical sunny summer month. I know today it's 6 p.m. and it's still bright sun outside my window. If I had solar panels on my house, they would still be generating tons of electricity and doing great. So my solar production during a typical sunny summer month is quite high. And my consumption from the grid is lower than that. You can see that in the green arrow showing the net metering credits that you are earning, because that's the amount you're exporting out to your electric grid. So now if we think back or forward 6 months from now, when it's cold and wintry and it's much grayer and it's definitely dark by 6 p.m., the solar you're producing is going to be much lower, as shown by the orange bar on the left, in the right graphic on the left. However, your consumption from the grid has stayed about the same. This means you're instead having to draw more power from the grid in order to make up for that difference. However, all the net metering credits you earn during the summer months are what help you pay for your electricity during the winter. So your net metering credits earned in the summer roll over month to month, and then you deplete them throughout the winter when you're drawing more power from the grid. It's important to remember that net metering credits can roll over from month to month, as I said, but they cannot roll over from year to year. That means you, on March 31st, when the net metering year ends, you forfeit the rest of any excess net metering credits you've earned throughout that year, and you start over the new net metering year on April 1st at 0. These credits are donated to low-income organizations and individuals who can benefit from a little bit cheaper power. A great discussion to have with your solar contractor is making sure to size your system appropriately, which I'll be talking about more in just a few slides. So once you're gaining all these net metering credits, what does that actually look like on your bill? So here's an example of what your bill can look like when you have solar. Pictured on the left, we can see the net meter reading at the beginning of the month and at 237, and the excess generation, so what you export to the grid, at 564, meaning your net period usage, so how much you were generating versus consuming, was negative 327 kilowatt hours. That means your billable kilowatt hours for this time period are 0, and that negative 327 gets added to your year-to-date baked excess generation, so it's really a positive. And you get to use that in this customer would get to use that in the upcoming colder months. However, if we look over on the box on the right, we can see that the bill for this month is unfortunately not 0, despite the billable kilowatt hours being 0. That's because in order to be a grid-tied solar system, you have to pay a certain amount of fees and taxes just to be connected to the grid at all. For this example, that was about $12.63. I believe today it's somewhere between $15 and $18. So while your bill is not 0, it's important to remember that is much less than the average utility bill here in Oregon, which is about $70 and going up consistently. I know we all just experienced some PG&E rate hikes at the beginning of this year, and so it's important to remember your solar power is staying the same price once you make that initial investment, and so you're more immune to those rate hikes past the taxes and fees, as $12 to $18 is definitely less than the average of 70. So now, as I said, your net metering credits go over from year to year, or from month to month, but not year to year. That means it's very important to size your solar system based on how much electricity you consume, and you want your solar system to meet and not exceed your expected usage. The average size here in Oregon for a solar system is about 8 kilowatts. And there are some other factors that can contribute to the size of your solar system, including the available space, your budget, and possibly some aesthetic concerns. Your solar contractor will ask to see some of your previous electric bills in order to appropriately size your system. So now, how can you know if your home is right for solar? So really quickly, no matter where you're at in Oregon, you do have enough sun in order to get solar, generally. Here we can see the arcs of the sun at the highest point in the sky, the summer solstice, and the lowest point in the sky, the winter solstice. Through this, we can see that the sun is always in the southern part of the sky. So as long as you have some roof space available in the facing south, east, or west, or any combination of those three, you can get solar. If you do have only north, northeast, or northwest facing roof planes, unfortunately, you are probably not a great candidate for solar here in Oregon. However, that is a great opportunity to look into some other options, such as community solar. So another thing that can prevent you from being able to go solar is shade. So even if you have a perfectly south-facing roof plane, if your home is very well shaded, it can really limit your solar resource and can prevent you from being able to go solar. However, don't cut down all those trees. Like I said, community solar would be a great option in this case. Next up, we have roof complexity. So pictured here on the left, we can see a very complex roof design. So where they have many south-facing roof planes, they're all very broken up and quite small, meaning to put a solar array on this roof, it would have to be many smaller arrays, leading to some increased fees as more racking and other materials would be needed. In comparison, we can see the roof on the right is a very simple roof plane with one continuous area. This roof would be much easier to put a solar array on. Another thing to consider about your roof is your roof condition. We recommend that you have at least 20 years of roof life left. This is because if you put solar on a roof that you're going to need to replace sooner, you will have to pay to have your solar panels removed and reinstalled on your roof. In this process, it's very common that solar panels can break or something else can get damaged, and you, again, will have to pay for someone to come and remove and put on your solar panels, which is just some added cost. So if you do have an old roof and you know you're going to need to re-roof in a few years, wait to get solar until after you've re-roofed your home. Next up, not only what's on top of your roof matters, but also what's under it. If you're going for roof-mounted solar, you want to be sure that your roof can support the added weight of the solar panel. To do that, you have to consider the engineering of your roof. No matter the rules wherever you are, trusses will pass even the most stringent of requirements, pictured on the left. However, if you just have rafters, like pictured on the right, which I know is more common in some of the older homes here in the Portland Metro, you might need to either pay for some extra engineering in order to either prove your rafters are sufficient or add in trusses. In some rare cases, even adding in trusses will not lend enough support for your roof to be able to support solar. Next up, we're going to talk about how home energy storage and solar can be complementary technology. So first up is energy resilience. Solar makes storage more effective by being able to charge your battery even when the grid is down, and storage makes your solar more effective as it gives you the ability to use power when the grid is down. The ability to use power when the grid is down is known as energy resilience. So here's just a very quick example of what solar and storage look like. We have the battery in the garage, and we have solar on the roof. So why would you want energy resilience? When thinking about going for energy resilience, it's important to consider what type of outage you are preparing for. Short, frequent outages, like those caused by storms and squirrels, are one option. Another are public safety power shutoffs, the first of which occurred in Oregon in 2020. This is when the utility company shuts down the grid in order to decrease the risk of a wildfire breaking out. Lastly, we have the Cascadia seismic hazard, where it is predicted the Willamette Valley could lose power for up to 6 weeks and even longer out on the Oregon coast. Short outages like those caused by storms and squirrels or public safety power shutoffs would be very easy to have enough battery storage to retain power throughout. However, getting power for a full 6 weeks can be prohibitively expensive. So when it comes to picking a battery, there are many brands and chemistries available, and many installers may specialize in one specific type of battery. If you are getting one battery now, but you know you'd like to add more later, it's important to remember that you are unable to mix and match batteries, meaning if you already have a Tesla Powerwall, you would be unable to add an E2 battery to that system. You would have to stick with the one you already have installed. Your battery and your solar panels do not have to be the same brand, though. And we have some photos of some examples of different batteries on the left as well. So as I mentioned, it can be prohibitively expensive in order to have battery backup for the length of an outage like the Cascadia seismic hazard, which is predicted to be multiple weeks long. In order to lengthen the amount of time a home can retain power for, many people elect for a partial backup, where you select just a few areas of your home to retain power rather than a whole home backup. In order to create a partial backup, your solar installer will actually create a separate essential loads panel. This is when some circuits of your electric panel are actually moved to a separate additional panel that is installed and in the event of an outage, only that separate panel would retain power through connection to the battery. This does add complexity and cost, but it can be a great option if you want to extend the length of time your battery will last. So this comes down to system sizing, which is a question of what needs power and for how long. What's typically selected are things like a fridge, a few lights, and maybe some outlets in common areas. However, the more things you have using power and drawing power from your battery, the shorter amount of time it will last you overall. If it is, of course, a nice sunny day, maybe it's a public safety power shutoff and it's nice and sunny out, your solar panels are able to recharge your battery. Of course, if it's a storm shutoff and it's snowing and your solar panels are covered in 3 inches of snow, they will be unable to generate you more power and help you recharge your battery. So relying fully on that can be a bit of a flip coin as to whether or not you'll be able to generate more power. So now a great question is when to install storage. There's 2 different storage options with either AC coupled storage, which is usually added after you've already had solar installed, and DC coupled, where it can be before your inverters and can be efficient in that way. If you install solar and storage at the same time, you do save some money, as you don't need to have contractors coming out to your home a second time and paying for extra labor. However, storage can be added to an existing solar system at an extra cost. It's also very important to remember that batteries require space. As you can see in the picture on the right, that's a pretty large battery setup with 2 different Tesla Powerwalls, but it's taking up what looks to be almost an entire wall with all the equipment that is needed. It's best if batteries can be installed near an electric panel, and they cannot be within an enclosed space, such as a crawl space or cupboard. They can be installed outside, but there can be some aesthetic conditions with that, and you may not like the look of it. So now that I've talked about all the different technologies, I'm going to talk about some of the incentives that are available. First up, we have the solar investment tax credit, which is 30% of the total cost of your solar system as a dollar-for-dollar tax credit that you would apply for on your taxes. So really quickly, I am not a tax professional, really wish I was, probably could have gotten a much better tax return if I was, but I am not a tax professional and this is not official tax advice. As always, only trust the tax advice of professionals. If you have any questions, I highly recommend seeking out the help of a professional. So as I said, this is a 30% dollar-for-dollar incentive. So 30% of the cost of your solar system you can get back on your taxes. It can be applied to both solar and storage. And if you do not have enough tax liability, it can be claimed over several years. There are lots of misconceptions with this tax credit. One common one is that re-roofing costs, if you have to re-roof in order to get solar, that those costs can be claimed. However, this is not true. If you have any questions about the investment tax credit when applying for it, I highly recommend, as I said, seeking the advice of a tax professional. Next up, we have the Energy Trust of Oregon Standard Solar and Storage Incentive. For solar, Energy Trust of Oregon offers $400 for PGE customers and $450 for Pacific Power. And for storage, they offer $500 per kilowatt hour with a $6,000 maximum per home for energy storage added. This is quite a generous incentive, and both can lower the cost of everything, which is great. Energy Trust of Oregon also offers Solar Within Reach, which is an income qualified incentive that offers $1 per watt of solar added up to $6,000 for Pac Power customers, and again for Pac Power customers, $750 per kilowatt hour added up to $10,000 off your total cost. And for PGE customers, it's $1.20 per watt up to $7,200 and $1,000 per kilowatt hour added up to $13,000. The household of 4 income threshold is very generous at $120,252. So even if you are middle income, it's a great thing to look into and see if you can qualify for. Now I'm going to go through some example budgets for a solar system in just a few minutes. However, before I do that, I'm going to really quick run through again some reasons costs can vary. As I said, solar systems are highly modular. So while these are some example budgets for what your solar system could end up costing, the price can vary greatly. So first up, when it comes to solar, the size of the system, whether or not you need to re-roof, if you need to do any sort of structural analysis, and how many incentives you can access can all impact the cost. And for storage, whether or not you're installing storage at the same time as solar, how many batteries you're adding, if you are adding in an essential loads panel, how far you're installing them from your electric panel, and again, how many incentives you can access all impact the cost of your system. So now here's an example budget of just solar. So this is for an 8 kilowatt solar system. So the cost before incentives across the board is $32,000. Then you receive the Energy Trust of Oregon incentive, which is $450 or $400, or if you're able to access that Solar Within Reach incentive, $6,000 or $5,400. That brings the out-of-pocket cost to the customer to $31,550. If you are income qualifying and able to access that Solar Within Reach incentive, that brings your cost down to just $26,000 or $26,600, depending on your utility. And after that, you then can claim the 30% federal tax credit, which is an additional 30% off, bringing the final cost to you as the customer to $22,000 or $18,000 if you are able to access that Solar Within Reach incentive. Next, we have an example budget for solar plus storage. That's an 8 kilowatt solar system with a 13 kilowatt hour storage added. That makes the cost before any incentives across the board $52,000. And with the Energy Trust of Oregon incentives, you're able to subtract about $3,000 or $15,500, cutting the middle if you are able to access Solar Within Reach. That makes the out-of-pocket cost to you before the 30% federal tax credit $48,000 or $36,000 if you can access Solar Within Reach. And you then claim the 30% federal tax credit, making the final cost to you, the customer, before energy savings about $34,000 or $25,500 if you can access Solar Within Reach, as I said. And our last budget is if you're adding storage after you've already paid for your solar system. So the cost of solar is $32,000, and the additional cost of a battery added after solar, whether we're assuming here there's a few years difference, or we're just combining the budgets into one so you can see, is an additional $23,000. You can claim the full Energy Trust of Oregon incentives on both of those. That decreases your cost and brings the out-of-pocket cost to the customer to be $51,600 or $39,600 if you can access Solar Within Reach. You then can claim the 30% federal tax credit and decrease your cost and make it about only $36,000 if for everyone, or if you can access Solar Within Reach, about $27,600. So those are some example budgets. I know those are some pretty big numbers. However, financing is very common. There are some loans tailored to solar that allow you to refinance after claiming your 30% federal tax credit, and your installer may have a financing partner. You can also talk to your bank or credit union about different options available to you. So now, given all this great information, how do you get started if you feel ready to dive into getting your own solar system? So I highly recommend working with an Energy Trust of Oregon trade ally. These are contractors who have been rigorously qualified and approved to offer Energy Trust of Oregon incentives. They are familiar with all Energy Trust design and installation requirements. And I forgot to mention, they are in order to access those Energy Trust of Oregon incentives that I just went over, you do have to work with a trade ally contractor. They will do all the work for you in applying for those incentives, and you will just see the amount that Energy Trust is giving you off your bill on the final bill they gave you as a discount. You have to do no extra work other than choosing a trade ally contractor. You can request bids from multiple trade ally contractors using the Energy Trust of Oregon solar bid tool. I'll be putting a link to the chat to that at the end of the presentation. This will connect you to up to 3 contractors who work in your area and will allow them to make you a customized bid based on your solar needs and where your home is located. Once you select your contractor and sign on the dotted line and complete all the paperwork, your contractor will handle all the permits you need except for the tax credit. You are ultimately responsible for applying for that. Excuse me. Depending where you're located in the state of Oregon, permitting can range from taking 2 to 12 months. City of Portland, I know, was at that 12-month. Apologies, hiccups. Energy Trust, the City of Portland was near that 12-month mark for quite a while, but I know their wait times for permits have gone down and gotten much better recently. Once you have all the permits done, the installation will take only a few days, and your contractor will manage all inspections and interconnections. And that's it. Getting your solar system is quite simple, assuming you work with a good contractor, and from then on, you just get to enjoy your energy savings. I'm going to go ahead and stop sharing my screen so I can grab those links for everyone. If people want to put questions in the chat while I do that, I'll be coming back to answer those in just a moment. Okay. Okay, I just stuck links in the chat. That links include the Energy Trust of Solar bid tool, as well as some information about community solar if you think your home might be shaded or you know solar isn't quite the right fit for you after this presentation. I'm also going to go ahead and launch the post-event survey while I begin answering questions. We got a question asking if we've ever done a presentation on the pros and cons of financing a solar system or of leases. So as I said, financing a solar system is very common. As those are some quite big numbers, I believe most people end up using some sort of financing. So it depends on your own financial situation, and you want to make sure you're being smart with your money. So definitely talk to a financial consultant and financial professional if you have more questions about that. Solar leases are not as common here in Oregon from what I know, based on how our net metering system works. However, doing a presentation on that is a great idea that I'll certainly discuss with my coworkers. Our next question is, how many years can the federal tax credit be carried forward? To the best of my knowledge, which again, I'm not a tax professional, it can be carried forward for as long as you need. I don't believe there's a time limit on it. We also got a question of what is the typical payback period with solar? That really depends on your usage. If you live in a house with many people in it, you have an electric vehicle or other high energy device such as a hot tub or something like that, your payback period is going to be a lot quicker than someone who is very conscious about their energy usage. Typically, we see payback between 7 and 15 years, and typically solar panels are under a 20-year warranty. So you are covered for usually the entire payback period and have some time when your solar panels are still under warranty after that period is completed. Yes, someone also added to my answer in the chat in Q&A, and I'll say what they say, that the paybacks are also dependent on how quickly the utility raises rates. So as the utility rates increase, the payback period also shortens quite considerably. That's very correct. Are there any other questions? I'm happy to stay on for as long as needed. Feel free to stick your questions in the chat. Well, thank you all for coming today. I really enjoyed talking with you all, and I hope you found this presentation very informative. If you have any other questions, you can reach us at info@solaroregon.org, or our emails are posted on our Eventbrite and on our website, so feel free to reach out to us there. Thank you so much, and I hope you have a great night.